Welcome to an example in which we have this triangle. It says in the image below, a line connects points A and B. Here's A and B, this line, along the hypotenuse of a right triangle. Yeah, it's a little bigger. The base of the triangle has a fixed length of 7, but point B moves vertically. So this point can go up, further up, so that the hypotenuse changes length, and so does the angle theta. So at this point goes up, 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 then this triangle goes like this, and that makes the hypotenuse get longer and this side get longer, and the bottom just stays at 7. Is that making sense? As that B moves up, right? Moves vertically, they said. So that's the idea. B is moving up, and as it is, your triangle goes taller, and so this side's longer and this side's longer, but the bottom just stays at 7. Okay. So with that in mind, first thing is write an equation that uses a trig function and involves the angle theta and the lengths x and 7. Make sure it is an equation with left side equal right side. So I want an equation. Left side. There's the answer. How'd they get that? Well, let's come back. So this is our angle theta right here. Okay, and then this is the side opposite. This is the hypotenuse because it's across from the right angle. Remember this stuff from trig? Therefore, this side must be the adjacent. And then we're going to use, so step one, we're going to use SOHCAHTOA. Remember that? Whenever you have a right triangle with a right angle, 90-degree angle, you can use SOHCAHTOA because it has hypotenuse, which is always set across from a right angle. So how do you know though whether you want to use sine or cosine or tangent? That's the trick students always ask me, Mr. And I don't know how to figure out which one. Well, that's why it's so important that I wrote hypotenuse, opposite, adjacent. Then you can see clearly how. I don't care about the opposite. Why? Because there's no x there, there's no number there, there's nothing there. I just care about hypotenuse, which is x, and adjacent, which is a number. I care about the two sides where I have something. So hypotenuse and adjacent. Which trig function involves hypotenuse and adjacent? Cosine. Hypotenuse and adjacent. So I go, oh, yeah, yeah. So that means the cosine of that angle theta is adjacent, which is 7, over the hypotenuse, which is x. It's adjacent over hypotenuse, which is what cosine says. Adjacent over hypotenuse, 7 over x. Adjacent is 7, hypotenuse is x. There we go. So that's the first, that's how we got that right there. Step one. Now, differentiate both sides of your equation to find d theta dx. Okay, so what we actually want to do, first off, they're kind of skipping a step, is we want to get theta alone first off. So I want to take this thing and get theta alone. So cosine theta equals 7 right. So we get theta alone. How can I do that? Can I divide by the cosine? I think you know by now you can't do that. Why? Because this is not multiplication. Make sure you know that what comes after a trig function, sine, cosine, tangent, f, g, h, whatever, that's not multiplication. I know it looks like it, but it's not. It's plug in to the functions. Plug into the toaster is the analogy I always make, right? This is like theta plugged into cosine, or just like f of x means x plugged into f. It's not multiplication. It's plug in. So therefore, I can't just divide because it's not multiplication. Well, then how do I get rid of it? You're going to do the opposite, which is cosine inverse. So whatever you do to one side, you have no choice but to do the same thing to the other. Those are opposites. They cancel. And theta is alone. Cosine inverse 7 over x, right? So that's good. Now, I'm going to do a little bit of a rewrite here. I would rather, it's going to be easier. Life's going to be easier for us if we make that 7x to the minus 1. See that trick I just did there? Because this guy's a fraction, and I want to change it to be not a fraction. It's still the same thing, right? 7x minus 1 means the minus x goes down, just like that. But this way, it's not a fraction. It's going to be easier for us to do the derivative, which is our next step. They want d theta dx. That's the same thing as theta prime. It's just two different ways of saying it. This is it's just two different notations in calculus. This is called Newton's notation. This is Leibniz. Anyway, you don't got to know that. So that's step 3. Now, step 3, we're going to take the derivative. So here we go. This will become theta prime derivative equals, that's kind of awkward, theta prime equals. Now, what's the derivative of cosine inverse. Do you know that? So let me put it up here. So if we have cosine inverse of x, the derivative is -1 over 1 minus x squared. So put that in your notes. So there it is. So, okay, so I got to do that. So I'm going to go, okay, so bring it on down here. I'm going to go -1 over the square root of what? 1 minus x squared. No, 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 not x squared, huh? You know better than that. Whenever we get a math or science formula and they tell us something about x, it just means whatever's here ends up going there and having a square on it. So what is there? This whole thing. So I got to put that whole thing, 7x to the minus 1, and that whole thing is squared. But we're not done there either. Why not? Because chain rule. The inside is not a simple x. So we must do the chain rule. Remember that? Whenever you're taking the derivative and the inside of what we did the outside, we did the cosine inverse, there it is. But if the inside is not a simple x, you got to do the chain rule, meaning you've got to take the derivative of this. Put it right there. You got to take the derivative of the 7x to the minus 1. So what is that? The minus 1 comes down, minus 7, oops, x to the minus 2 because you subtract 1 from the power. Now we've got the derivative. Now we've got it. Okay. Now they wrote it like this. So, which is fine. I wrote it like this. Oh, yeah. You might wonder where'd they get that x squared? Ours is fine. You can type this in. It's all good. It's fine. See how they have x squared on the bottom? That's because we have x to the minus 2, so that'll go to the bottom. Oh, you might wonder, what about 7 on the top? Well, that's because this is over 1, so this will go to the top. So I'll show that if you want. So, um, this is going to become, so minus 1 times minus 7x squared is going to be plus 7x to the minus 2 on the top, right? Because it's over 1 right here, over 1. So then on the bottom, we have 1 minus 7x to the minus 1 squared. Okay. Now they wrote it like this. I actually like mine better. If you want it, it'll take this. Type this in, it'll take it, or you can put that x to the minus 2 down here, be x squared, right? Negative powers. But why? This is great. I like this. I like this better than what they did with the fraction. Anyway, so there's the derivative. Last step. They said, all right, now x is 9. So now you just take that thing and step 4, plug in x is 9. So put a 9 there, put a 9 there. Hit the buttons on your Desmos calculator, and there you go. You'll get that answer. So there we go.